Hey guys, welcome to the Unit 4 test review. So by the end of this review and before you take your test, you want to be able to say these 5 things. I can find the unit rate, I can solve systems of equations, I can compare slopes, I can write linear equations, and another word for that is function rules. So those two things can be interchanged. And I can identify linear versus nonlinear functions. So let's go ahead and jump in. It says, what is the unit rate of miles per hour? So if we look over here and some of their points, they have a point right here, and that's located at 2,120. So that says that in 2 hours, they travel 120 miles. But we don't want to know how many miles they travel in 2 hours. If we're dealing with unit rate, it needs to just be 1. So we want to know how many miles they travel per 1 hour. So if they go 120 miles in 2 hours, we could take that and we could divide it. And that would tell us that they would go 60 miles in 1 hour. That is our unit rate, is 60 miles per hour. So anytime we're dealing with unit rate, we want to get it down to just 1 unit. And you can also look at the graph and see this. If you went over here to 1 and followed it up, you would see that it was 60. Solve the system of equation by either graphing or substitution. All right, I love graphing because if you look at the two graphs, wherever they cross is your point. So I am going to go ahead, I would just use Desmos, and I am going to show you Desmos, but because you also need to know how to graph things, let me mention how to graph it. If I wanted to graph this first equation, what you do first is you put your y-intercept on the y-axis. So this is my y-axis, and I know at 2, I have to have a point because that's my y-intercept. Then I would do my slope, and your slope is a number attached to x. If it's not already a fraction, you want to make it a fraction by putting it over 1. And because it's a slope, you're going to do rise over run. And since our slope is -3 over 1, that means that from my y-intercept, from this point, I'm going to rise down 3, 1, 2, 3, and I'm going to run over +1. So this would be that first line. I would put 2 on the y-axis, and then I would rise down 3 and over 1. So if I wanted to graph this one, I would put my y-intercept on there first, so I would have a point at -3 on the y-axis, and then I would do my slope. From the y-intercept, not from 0, 0, from the point you've already put, you're going to rise 2 and run 1. So this would be this line. And remember, the solution to your system of equations is wherever they cross. Wherever they intersect is your solution. And in this case, they intersect, and you always want to write these as ordered pairs, x, y ordered pairs. So the x value was +1 and the y value was -1. This is your solution to the system of equations. Now, just as a reminder, you can use Desmos. You do not have to graph it by hand unless you want to. So you could go over here and you could do y equals, I already forgot what they were, -3x + 2, and then hit enter or the blue button. And then you want to also type in the second equation on the same graph. So my second equation was y equals 2x - 3. And then you're going to look and see where do they cross. And if you click on it, it'll actually tell you the ordered pair, 1, -1. So the system of equations, in order to solve them by graphing, you would graph them and see where they cross. That is your solution to the system. All right, write the function, if I could read, which function represents the proportional relationship shown in the graph? Okay, we're going to talk more about this in just a minute, but I want to go ahead and mention that if it's going to be a proportional relationship for x and y, it has to go through 0, 0. That's going to be an important thing for later on. That helps you identify which ones are proportional. But if I want to write the function, I'm going to write my equation, my y equals mx plus b. Now remember, in this slope-intercept form, m is the slope and b is the y-intercept. So when I go to write my function rule or my linear equation, the first thing I like to do is find the y-intercept. So I'm going to look at my y-axis, and I'm going to follow it down until my line crosses it. And my line crosses the y-axis at 0. So I'm going to put that for my y-intercept. And then for my slope, I need to do my rise over run. So I know I'm going to start at 0, and I need to follow it along until the next point that crosses the grid. And notice right here, this crosses the grid perfectly. So I'm going to do rise over run between those 2 points. I'm going to rise up 1, 2, 3, 4, 5 spaces, and then I'm going to run over 1, 2, 3, 4. So I'm going to rise 5 and run 4. So this is my function rule. And a lot of times you won't see the 0 on the end. So it'll probably just be written as this, y equals 5 over 4x. Which linear function has a greater unit rate? Okay, so for unit rate, remember we're getting it down to 1 unit. So if we look here, we want to know what it is for 1. So for 1 hour. So if we follow this up to 1 hour, that tells us that he's 50 miles from home. So this unit rate is 50 miles per hour. And now let's look at Kevin's trip. For unit rate, again, we want to get it down to 1. So if you look here, we don't have 1 represented. So we have to solve for it. But we know in 2 hours, he goes 90 miles. So since he goes 90 miles in 2 hours, to figure out what he does in 1 hour, you could divide that. And so he goes 45 miles per 1 hour. So if you compare these two unit rates, this one's 50 and this one's 45, and we want to know which one is greater, that would be 50, because 50 is bigger than 45. Select the quadratic function that is represented by this graph. Okay, so we know for it to be a quadratic function, it has to have an exponent of 2 on x. And in this case, the whole graph has been shifted down 1, 2 spaces. So our y-intercept here, you can kind of still think about it as the y-intercept. It's going to cross at -2. So I know that this is not a linear function. It is not y equals mx plus b. That's absolutely not what it is. But you can kind of still use that knowledge to figure out that if it crosses the y-intercept at -2, this graph is going to have to end in a -2. And so I'm kind of connecting prior knowledge, and I am going to guess that this is my answer. But I need to make sure that I double check it. This is a test grade. So I'm going to go to Desmos, and I'm going to type all these in and see which one looks correct. So y equals x squared minus 2. That actually is the correct graph. See how it crosses down here at -2? If you had typed in any of the others, like let's do this one, y equals parentheses x minus 2 squared. If you had typed this one in, see how it's not the correct graph? It's over here at +2. So you can use Desmos to figure this out. I use some prior knowledge to kind of narrow it down, and then I use Desmos. And one thing that I want you to, a couple of things that you need to know. A quadratic function does have a power of 2, and the shape of this graph is called a parabola. So that's just a bunch of other math knowledge that you'll need to know as you're reading through the test. And if we look at this, if we wanted to pick out which one of these was a quadratic function, we're looking for when we have x squared. So here we have 25 over x. That's not quadratic. This one has x squared. This one doesn't have x squared. That's not quadratic, and that's not quadratic. So for it to be a quadratic function, it has to have x to the second power, and the shape is called a parabola. All right, which linear function has a positive slope? So there's a lot of different ways to find slope. In this situation, we have an equation. So y equals mx plus b, and m is going to be the slope. Now you got to be super careful. They're trying to trick you here. They're trying to get you to say that the slope is -5. But the slope is always the number attached to x. It's the coefficient of x. So if we look down here, they've switched the order up on us. So this really should be written as y equals 2x minus 5. But either way, the slope is positive 2. So that does not have a negative slope. And then if we want to find slope from a table, we're going to find the change in y over the change in x. So if we look for the change in y, we go from -6 to -5 to -4 to -3. So we are adding 1 each time. So the change in y is 1. And then for the change in x, from -3 to -1, we're adding 2. And then we add 2, and then we add 2. So our change in x is 2. So here our slope is 1/2. Oh, both of these have a positive slope. What in the world? Well, that was a mistake on my part. Sorry, y'all. One of these should have had a negative slope. Let me change this table so that it makes sense. Let's go from, is this going to let me type over it? Oh, of course not. Okay, we will change this. We'll pretend like this had said +3, +1, -1, and -3. Then we would have been subtracting 2 each time, and that would have made that slope negative. So this slope was positive, and that one actually was 2, but I just changed it so now that one has a negative slope. Which point is the solution to the system of equations? Now again, you can solve this any way you want, but I like to graph. Graphing is my favorite. I'm very visual. So I'm going to go to Desmos and I'm going to type this in. Y equals -x plus 7. And then I'm either going to hit enter or I'm going to hit this blue arrow button. And then I'm going to type in the next one. Y equals 2x plus 1. And wherever they cross is my solution. Since they cross right here, my solution would be 2, 5. So that would be my solution to that system. Which graph or graphs represent a proportional relationship between x and y? So I kind of mentioned this earlier, but if it's going to be proportional between x and y, it has to go through 0, 0. It has to go through the origin. So this one goes through 0, 0, and this one goes through 0, 0. The others do not. Notice here it crosses at 2, here it crosses at 2, so those are not proportional. These are the ones that would be proportional because they go through 0, 0. Write a function rule for this table. Okay, so function rule is just another word for linear equation, so we're going to write our function rule in this form, slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So there's a couple different ways you can do this. You could plot the points and you could write it from that, or you could find the slope and the y-intercept just from the table. So for the slope, we need to find the change in y over the change in x. So if I look here, my change in y, I'm adding 4 each time. For my change in x, I'm adding 1 each time. So for my slope, it would be 4 over 1. And then for the y-intercept, usually what we look for, if it's going to cross the y-axis, the x value has to be 0. So wherever it is on the y-axis, the x has to be 0. In this table, we don't actually have where x is 0, but we can follow the pattern to figure out what it would be, right? So if I go backwards 1, I would need to go backwards 4. So 6 minus 4 would be 2. So in this case, my y-intercept would be at 2. Usually, if you look at a table, it'll have 0 for x, and then whatever the y value is your y-intercept. If it doesn't have 0 for x, then you need to continue the pattern until you find what that would be. All right, we are going to continue this review on the next video.